Good afternoon, everyone. I'm Queenie Tachada, and now I'm going to tackle about the five types of sailing: the parallel sailing, plain sailing, middle latitude sailing, Mercator sailing, and the great circle sailing. So let's start. But before we start, let's first remember this. Same direction, both latitude or longitude, subtraction, and vice versa. But if same direction paired with longitude or latitude and D-lat or D-long, addition and vice versa. The thumb rule and the factors in determining the true course. So now let's start the first type of sailing, which is the parallel sailing scenario. A tanker vessel departed from lot 20 degrees 10 minutes south, long 45 degrees 25 minutes west, and arrived to lot 20 degrees 10 minutes south, long 60 degrees 15 minutes west. Determine the course and distance. So first, let's put the given. Let's first find the D long. The value of longitude 1. So same direction, both longitude we need to subtract. 15 minus 25 is cannot be. So borrow 1, which is equivalent to 60 minutes. 60 plus 15, 75. From the direction, longitude 1, and then longitude 2. So the direction is going to west. Then we need to convert this into minutes. 14 times 60, then plus 50. So now let's solve the distance. Having a formula of, then we need to substitute the value. D long is equals to 819 minutes. Slot, which is this. So the answer is 835.4 nautical miles. Thus, our distance is 835.4 nautical miles. And for the true course, we base this D long west. Since parallel is only due east and west, then we have a true course of 270 degrees. That's all. Now let's solve for the plain sailing. A passenger vessel departed from 20 degrees 5 minutes north, 80 degrees 5 minutes east, on course of 160 degrees through course for a distance of 310 nautical miles. So let's now determine the vessel's arrival position. Given, so the vessel's arrival position is what we're going to find. Solutions. Let's first convert the true course to course angle. So 160. Let's find where 160 belongs here. So south to east, minus 180 degrees. South. So we have now the course angle. Second, let's find the DLAT. Having a formula of DLAT equals to cos 20 times 310 is equals to 291. So we need to convert this into degrees and minutes. 291.30 divided 60. We have 4 degrees multiply 0.855 to 60. We have 51.3. Then second, we need to solve for the lot B since we have the D lot. So basing from this one, we have lot and D lot, different directions. So we need to subtract this one. Since we cannot subtract 5 to 51.3, we need to borrow here. 1 degree is equals to 60 minutes. We need to copy the sign of those who have the bigger volume. So we have our lot 2. So the next step is to find the M lot. Having a value of latitude 1 and latitude 2. So according from thumb rule, having the same direction, we need to add that 1 and divide it by 2. We're gonna convert this into degrees and minutes. So copy 17 as degrees. Then multiply this one into 60 to make this as a minute. So we have the MLAT of 17 degree, 39.3 minutes south. Then the next step would be solving for the departure. Departure is equals to distance times sine course. The value of the distance is 310 nautical miles multiplied by the sine 20 degrees. For the departure, we have to copy the sign of this one, the east. Then now let's solve for the D-long. So our departure would be 106.03 minutes. Divide cos m lat. We're gonna divide this by 60. Multiply this by 60. Then now let's find for longitude B. So from this one, having the same direction, we need to add this one. So this is now the arrival position of the problem. So now we are here in the third method of sailing, the mid-lat sailing, or also known as the middle latitude sailing scenario. A light ferry's initial position is lat 15 degrees 21 minutes south, long 130 degrees 15 minutes west, and arrive at lat 17 degrees 12 minutes south, long 139 degrees 5 minutes west, find the vessel's course to steer and distance to run. So the given are, so now let's find first the DLAT. So in order to find the DLAT, we need to subtract or add the latitude. Middle latitude sailing and the plain sailing is the same, since middle latitude sailing is the combination of plain sailing and parallel sailing. So according to this, having the same direction, we need to subtract this one. As we cannot subtract 12 to 21, we need to borrow here 1 degree is equivalent to 60 minutes. So 60 plus 12 equals 72. And we need to convert this degrees minutes into a whole minutes. So 1 degree multiplied by 60, 60 plus 51, DLAT is equal to 111 degrees south. So now let's find the D long. So same here, we need to subtract longitude 1 and longitude 2. The direction would also be west. Convert it into a whole minutes. 8 multiplied by 60. 8 multiplied by 60 is equals to 480 plus 50 minutes. D long would be equals to 530 minutes west. And now let's solve for the MLAT. We have latitude 1, latitude 2. Since the same direction according to the thumb rule, we need to add this one and divide it by 2. 31 degrees 33 minutes south divided by 2 is equal to 15.775. Then convert it into degrees and minutes. So 15, we have 15 degrees, 0.775 would be multiplied by 60. So we come up with 46.5. So we get the MLAT. Then now let's find for the departure. So we have a formula of departure is equals to D long multiplied by cos MLAT. We have a value for D long, 530 minutes, multiplied by cos MLAT, which is 15 degrees 46.5 minutes. So the departure would be 510.04 minutes west. We get this sign from our D long. Then the next step would be finding its course. We have the formula of course, which is tan co is equals to departure divided by DLAT. So our value for the departure is 510.04 minutes divided by the DLAT, which is, the DLAT would be 111 minutes. Okay. Then shift tan. Then we need to copy the sign for DLAT, which is south. DLAT 77.7 degrees, and then the direction of the long west. Then to find the true course, we plot this one. So southwest. So according from this, southwest is we need to add 180 to find the true course. The course angle would be south 77.7 degrees west, add by 180 degrees. Our true course would be 257.7 degrees true course. And lastly, we need to find the distance. We have the formula for distance is equal to departure divide by sine cos. Distance would be, therefore the light ferry would be steering from true course 257.7 degrees and a distance to run 522.4 nautical miles. So we are now in Mercator sailing, having a scenario of having an initial position of 10 degrees 2 minutes north, 83 degrees 2 minutes west, and course 250 true course for a distance of 4,320 nautical miles. The captain of the BBC Marmara vessel asked the second officer to determine their vessel's DMP and arrival position. DMP are the difference of meridional ports. So the given are, so let's first convert the true course into course angle in order to avoid getting a negative answer. So our PC is equal to 250 degrees. So 250 plotting here, 250 is located here, southwest. So let's add 250 to 180 degrees. 250 plus 180 degrees is equal to 430 degrees. Basing this one, the direction would be south to west. Now let's find for the DLAT. So we convert this one in order to avoid getting negative answer here in DLAT. If we use this in here, we get a negative answer, but same answer would be the result. Having a formula of DLAT is equals to distance times cos course. Distance is equals to 4,320. We get a value of 1,487.8 minutes south. So now we're gonna convert this into degree minutes. So this one, we're gonna divide this by 60. We have 24 degrees. Multiply this by 60. 47.8 degrees south. So now let's find the latitude 2. So according here, having different direction, we need to subtract this. 14 degrees, 45.8 minutes south. And now let's solve for the DMP. DMP is a difference of meridional parts. So the formula of MP is equals to MP is equals to what? Divide 2 plus 45 equals 10 ans log ans multiplied by 7915.7 minus sine lat multiplied by 23.3. So we need to find the DMP between the lat 1 and lat 2. Lat 1 is equals to, so we have come up into a value of 601.04 more. Then L2 is equals to 889.83 minutes south. So we have a different direction, both latitude. So we need to add this one. So we have 1,490.87 minutes DMP. So now let's solve for D long in order to find the longitude 2. So we have a formula of D long is equals to tan course multiplied by the DMP. So tan course, so 250 multiplied by 1,490.87 minutes is equals to 4,096.1366. So we need to convert this into degree minutes. So we must divide 4,096.1366 into 60. So we have D long is equals to 68 degrees. Then multiply this into 60. We have 16.1 minute west. Then lastly, we need to solve for longitude 2. Oh, sorry. This is west. So having the same direction, so we need to add. So the vessel's DMP is 1,490.87 minutes and its arrival position is L2 is equals to 14 degrees, 45.8 minutes south, and longitude 2 is equals to 151 degrees, 18.1 minute west. So that's all. method of sailing, which is the Great Circle sailing scenario. A cargo vessel will be sailing from lat 20 degrees 21 minutes north, long 28 degrees 3 minutes west, to lat 28 degrees 44 minutes north, and long 79 degrees 39 minutes west. So what is asked? The great circle distance, the initial course, the final course, the latitude of vertex, the longitude of vertex, and the great circle track. So many. So we have a given of. So first we need to find the D long. So for D long. So having the same direction, we must subtract this 2. So the direction would be west. Then the next step will be solving the great circle distance. We have a formula of then substitute. Then first, we need to multiply this 3. Then this. Then cost shift. We have. So let's convert this into degree minute. So we multiply this 1 by 60. Then convert this into a whole minutes. Multiplied by 60. Then add 19.5. So this is our great circle distance, 2,839.5 nautical miles. Before we proceed to final course, we first get the initial course. So we have a formula of cosine initial course equals to sine L2 minus cosine distance multiplied by sine L1 divide sine distance and multiply cosine L1. So substitute the value into this formula. This one, cosine 47 degrees 19.5 minutes multiplied by sine 20 degrees 21 minutes. Divide by this one. Then subtract 0.4807337 to 0.2357211. Subtract this. Divide 0.2450126 to 0.6893228. Then shift cosine of 69.2. First, we need to copy the sign of the latitude 1, which is north, 69.2 degrees. Then the sign of the D long, which is the west. Now, Let's track this one. Northwest, then we need to subtract 69.2 to 360 degrees. Our initial course is equals to 290.8 true course. And now let's get to our final course. Having a formula of cosine FC, which is final course, sine L1 minus cosine distance multiplied by sine L2 divide sine distance multiplied by cosine L2. Then substitute the values. We use this value instead of this. Sine L1 is equals to 0.3477539 minus the cosine 47 degrees 19.5 minutes multiplied by sine 28 degrees 44 minutes. We have 0.32560 divided by 0.6446814. So subtract this two. We have 0.0218939 divide 0.6446814. Then have 0.0339608. Shift cosine. So we have 88.1. Having the opposite sign of latitude 2, which is the opposite sign of north, is the south. 0.1, then the sign of the belong, which is west. So south to west, here south to west, we must add 88.1 to 180 degrees. So we have 268.1 degrees reverse. So our final course is 268.1 degrees true course. Then now let's solve for the latitude of vertex. We have a formula of cosine lat of vertex is equal to cosine latitude 1 multiplied by sine initial course. So substitute cosine L1 is equals to 20 0.876479.24567. Then shift cosine. We have 28.779475.2. Then we must convert this into degree minutes. So our latitude of vertex is equals to 28 degrees, 0.779475 multiplied by 60. We have 46.8 minutes north. Sine is according to the latitude 1. So we have the latitude of vertex. We have 28 degrees, 46.8 minutes north. Then now let's solve for the longitude of vertex. We have the formula of sine d long vertex equals to cosine initial course divided by sine latitude of vertex. Then substitute. So we have 0.73755815. Then shift sign. We have 47.5258019. Our d long of vertex is equal to 47 degrees. Then multiply this by 60. We have 31.5 minutes west. Sine according to the d long. Then d long v. So we have long v. The longitude of vertex is equals to the same direction longitude paired by d long is addition. Then we need to add this one. So we have now the longitude of vertex equals to 75 degrees 34.5 minutes west. So we now find the value of the great circle distance, the initial course, the final course, the latitude of vertex, and the longitude of vertex. So now let's solve for the great circle track, which is the track for the longitude and latitude. Let's add first another manila paper. So now let's compute the great circle track of longitude and latitude. Our x is by 10. So we need to find a value that will be result to 10 degrees, 20 degrees, 30 degrees, so on and so forth. So first, we need to solve for d long vertex x1. Longitude v is equals to 75 degrees 34.5 minutes west. Then our longitude of x1 is equals to 0.65 degrees 34, which will come up to d long x1 is equal to 0.10, our target x, 0.0 west. Then solve for the x2. Subtract this. We have d long v x2 is equals to 0.20 degrees 0.0 east. Then we lastly solving for d long of vertex x3. So now let's solve for the latitude. So we have a formula of tan lat x1 is equals to cosine d long v x1 times tan lat v. So substitute, we have shift tan is equals to 28.41133934. 28 degrees, multiply this by 60. Then the lot of x2. The same formula, but this is x2. Substitute the values. Then multiply this 2. We have 0.516133. Shift tan 75. Our lot x2 is equals to 27 degrees. Multiply this by 60. 18.1 degree north. Then lastly, solving for lot x3. Substitute again. 0.47577079. Shift tan 25.44082020. Lot x3 is equals to 25 degrees. Multiply this by 60. We have 26.4 degrees. 26.4 minute north. So now let's track the latitude points along the Great Circle track. The successive latitude points along a Great Circle track. So now let's plot it. So here is the pole, then the arrival position. You have this B, which is the arrival position is located here, which is the L1, longitude 1 and longitude 2 rather. Then the angle, you have this one, the VX, the vertex, the LX1, LX2, our LX3, and our departure. So now, this is the longitude of vertex and the latitude of vertex. which are the LAV 28 degrees 46.8 minutes north, and longitude of vertex equals to 75 degrees 34.5 minutes west. Then this is this one and this one. LX2 is this one and this one, while LX3 is this one and this one. This is the departure position. So that's all. Thank you.